My name is Silvia, and well, we're going to talk about the Electron applications, hence the topic, only an Electron away from code execution. So who am I? What do I do? My daily job, I work as a web application pen tester in an Estonian-based company called Clarified Security. So yeah, Estonia is a country, and we're right below Finland. We finally started having our own IT security meetups in Estonia as well, where I'm one of the co-founders. And well, I'm also part of the Black Hoodie movement, so part of these lovely ladies who you can see in the audience here today. And 2018 actually happens to be the very first year for me to have any kind of conference talks. And as part of the project that I'm presenting you today, I also managed to get my very first CVEs here for the Electron applications. So those of you who have never heard of Electron applications or the Electron framework itself, it's basically a framework which enables you to build desktop applications, but to do so for multiple platforms, as well as, in this case, if web technologies happen to be something that you're familiar with. So I'm talking about HTML, CSS, and JavaScript here. Then you should have a really easy time in developing your own desktop applications as well. And Electron actually came around already 2013, but back then it was known by the name Atom Shell. And later in 2015, it was renamed to what we know of today as Electron. And the team behind the whole project is actually the GitHub team itself. So what actually got my interest to look into this topic in the first place was I started noticing people were coming up with these articles and tweets and news bulletins about how they were having code execution in desktop applications. But what made it interesting was that it was suddenly in a manner where, okay, you would find it on one platform, but it was suddenly on all of those because it was this kind of a framework. And it was happening via JavaScript. And one of the tweets that actually in particular got my attention here was for a really funny idea. So if you dig deeper into this tweet, so can you actually imagine a team or a person coming up with an idea to literally reinvent the whole essence of what is a desktop application? And to build a framework which would definitely ease your way into becoming a desktop developer if you come from the web background, but to build a framework in such a manner that if you come with all your mistakes that you might do in the web world, and you do those things on the desktop world, so the simple vulnerabilities on a desktop would actually evolve into something much more nasty. So I'm talking about the cross-site scripting vulnerability that occurred in Electron framework and in the applications, which there evolved into code execution like this. So where it's actually coming from, I'm going to show you that too. But yeah, so this is one of the really funny ideas behind what I'm presenting you today. So a lot of the big names have adopted the Electron framework. So you can see the Slack, the GitKraken, the Wire, Slack, WordPress, you name it. As well as Electron on their official site also has this huge list of applications that they proudly promote that they're using this framework, and they also announce the monthly apps that they're super proud of. So if you see from the numbers, in 2015, Electron had a bit over 100,000 downloads. So to 2018, it actually reached with over 4.3 million downloads. So the user base there has grown a lot. People are really interested in using the framework, as it's actually super easy if you really dig into it. And when I'm talking about the framework, what it really means, what I'm talking about, is its three core components. So there's the Node.js, which gives you all the desktop-like feeling that Electron is trying to provide you with. And then there's the module from the Chromium project, which is used here in order to show all the content you want to show to your user within the respective browser windows you're creating for the application, as well as the V8 JavaScript engine, which sort of ties it all together as Node and the Chromium share a single instance of it. So similarly to Chromium, Electron also uses multi-process architecture. So there's the main process, and then you can have one or multiples of render processes. And each of the processes' resources and memory, they're running concurrently, and they're isolated from each other. So this works here as a safety mechanism. So if a fatal error would occur in one of these processes, then the rest of the application would still be able to continue on. And to demonstrate to you what a super simple Electron application could look like, we can take a look at these 3 files. So we have a main.js file, we have index.html, which holds all the content we are going to display here, and then the package.json, which obviously has all the dependencies, the versioning information, then the startup scripts, and the application's entry point. So this is here the main.js file, which gets executed within the main process. And what's happening for the main process? Electron as a framework comes with a framework-specific APIs. And these APIs are divided between the main and the renderer processes. So you can access them from one or the other, and then they have a set of APIs that are actually accessible from both of those. And in this example, you can see the browser window API, which by the name you can obviously see. We're going to use it to create a new browser window here. And you can give it a set of attributes. And later on, the second line that I've highlighted in blue, we are going to use browser window in order to create the new window for us. And later, we're going to specify that the content for that particular window should come from within the index.html file right here. So what happens when we create that browser window? Then a set of web preference options becomes available to us. These options are actually really important from the perspective if you're trying to find vulnerabilities in Electron applications, because they can make a really big difference on how far can you actually go. And for example, here, it is possible to control whether the users of an Electron application are able to access the developer tools. So on one hand, it's quite useful. You could try give access, and maybe people will find bugs in your application that will report it, as well as it would be useful for me. So because we're dealing with JavaScript, I can see the whole source code right there, right? So I can identify also where the vulnerabilities lie in this application. Then you can also use the sandbox option right here. So sandbox option is something you can use in order to sandbox your renderer processes. But bear in mind here that since we're dealing with a framework that tries to give you desktop-like experience, which comes because we're using the Node.js engine, which is enabled, then if you decide to sandbox the renderer processes, then automatically by design, the Node.js engine would be disabled. So all the desktop-like experience would be lost here. So maybe question it a bit whether it's something you would like to do or not. So in case of a static page, why not? Then it's also possible to control the usage of JavaScript in the application, as well as by setting the web security option to true or false. You could even twiggle with the same origin policy. Then, as part of this project, the very first one, node integration, was something that I took a particular interest in, because this is what gives the extra access to the underlying operating system on which the application is currently running upon. And to demonstrate what the usage of this option actually looks like, let's actually see inside what's the content of the index.html file here. We try to require the OS module in order to simply display the home directory, the platform of the machine on which the application is currently running upon. And then we simply display it back to the user. So if we place this index.html file into the context where we have a browser window where we specified that node integration should be set to true. Then we get exactly what we asked for. However, changing the same option to false, and there's a blank space there, and instead from the console you can see that we've had a reference error as the Node.js engine is disabled, so we cannot require the stuff that we need here. So while in this example, this is what we expected, right? But what if we have an application using Electron framework, and in that application we have a simple form. Let's say you have a space for the email, you have some phone numbers maybe going on there, and you submit it, and then it's displayed back to you. So the perfect case scenario where you could go and look for a cross-site scripting vulnerability. And you take the same content we had within the index.html file, you maybe modify it a little bit, but you paste it in the user input field right here. So this example, it's actually a really simple script. It does basically the same thing. And because the cross-site scripting vulnerability is occurring in this application, and by design, node integration is set to true, which means we have access to the operating system, we can talk with it. So we are able to ask a question here that the developer did not intend us to have asked, right? So this is an example where cross-site scripting vulnerability has evolved into code execution. So I would say this is a pretty nasty thing that would happen. And in a web application, this would be caught by the bounds of the browser, right? So not even that, but it actually gets even nastier. I'm sorry for the minions. If you hate them, don't kill me. If you examine by default how Electron applications are launched, so the render processes by default are always launched without the protective layer of the sandbox, as well as the node integration is always set to true. So Electron does everything for us to make sure that applications are working. You don't need to touch anything. It's actually maybe better if you don't touch anything. Maybe you will break it. Who knows? But yeah, so maybe that's a question to ask. Well, maybe it's a little bit too much of a freedom here. So that information got me to two assumptions here. If something already works out of the box, then maybe there is the mentality behind that it's better not to touch it, maybe I will break it, right? Or the other way, if it's already working, why should I even bother? Because it's doing everything that I wanted anyways. So my first assumption was, if people have the choice not to go and twiggle with the node integration option, they probably might not do it. The second assumption here was, well, me as a pen tester, or probably all of you here, cross-site scripting vulnerability is super common. So what if you have these adventurous web developers who now come over to building all these glorious desktop applications? They did the mistakes in their web applications. They were maybe aware of them. And then now they come over to the desktop environment. And they're thinking, how on earth can web vulnerabilities actually occur on a desktop? So maybe they're a little bit on ease here, not going to pay attention to it. And I would say maybe the probability here to have the web vulnerabilities on the desktop because of this framework is now suddenly higher. So what I continued to do was actually really simple. So these 3 steps. I decided, since the GitHub team is behind it, I went straight to GitHub, chose a set of Electron applications from there. I tried to gather information about what kind of browser windows they were creating, how they were creating it, and what were the web preference options they were using. And finally, well, I just did my best to find a cross-site scripting vulnerability. So if all those 3 points happen to be there, then I would end up with a code execution here, right? And as it was the first time I was dealing with Electron applications, then I decided to gather some background information on what I was looking at. So I wanted to know what kind of Electron-specific APIs they were using. So that would show me which kind of functionality the developers really cared about. then I wanted to know what was the remote content they were adding and how they were adding it. And finally, the options which I was clearly the most interested in. And what it all came back, I saw that, Electron has close to 60 framework-specific APIs. And these applications, they made use only of 16 of them. So that's not even a half. And the most important functionality for the developers here actually lay within the main process modules. And one of the modules here that also shows that was the heavy usage of the remote module. So remote module in Electron project is something that you can use if you want to access the functionality within the main process modules, but you want to do it within, from the renderer processes. So that was really common thing that I noticed here. When it came to the remote content, I went through Electron documentation. I gathered some bits of data here that they were actually suggesting you to add it in these 4 ways. But when I started to go through the source code of these applications, I actually saw that none of the developers was really using any of those ways. And instead, they preferred a different approach. So whenever they were including any kind of remote content in their applications, they decided to use the shell open external method in order to open it within the user's default browsers, whether it was Chrome or Firefox or anything else. So maybe they felt a bit more safe, but who knows? And funnily enough, in many times, the content was actually still served over HTTP. So maybe that's already the point here as Electron, to display the content in Electron, and you want to do it over HTTP, this is not allowed by default. So maybe that was their way how to still do it, and everything would work fine. When it came to the web preferences, let me remind you here the assumptions that I made before. So if a person has a possibility not to go and twiggle with the options because everything is working, then this proved the point here. So I had 30 applications I was looking at. These 30 applications, they had 52 browser windows. And within those 52 browser windows, we would have 52 sets of web preference options, right? And this would mean that I had 41 cases where the person had not even set any value to any of the web preference options whatsoever. It wasn't there. Then in 5 cases, the developers had actually went ahead and set the node integration option here to true. However, if you remember, by default, Electron applications and their renderer processes, they already launch with that option set to true anyway, so that would not make any difference. And in 6 cases, which I think developers actually understood what this option is doing, why is it there for, maybe they had some static content there, and they realized, okay, the best option here is to set it to false. So by these numbers, I had pretty good odds to go and find cross-site scripting vulnerability, right? So 46 chances. If this would occur, I would immediately end up with a code execution. How did it look like was, well, I spent 5 minutes on each of those applications. And from those 30, 10 came back immediately with a cross-site scripting vulnerability. And out of those 10, 9 was what I was looking for. So I had cross-site scripting vulnerability in the context where node integration was set to true. So if you look closely at the descriptions of these applications, funnily enough, I actually found out that if you look into these applications, then people are really into timekeeping applications or information sharing applications, or basically anything that helps you to manage anything. And how did it look like? So the first example here is the Lianode node keeping and sharing application. And on their site, they actually really encouraged you to share your notes with your friends or coworkers. So they had the web version, they had the desktop version, and the best part about it was that you could synchronize the data between those two. So if you happen to share your information, then the scenario here was that, well, the vulnerability didn't occur on the web application. So that also proves a point. If you come to a new environment where you do not expect web vulnerabilities to occur, you feel too relaxed. So as soon as you have some nice friends creating you some new nodes in the application, you synchronize the data from web to your desktop, and code execution. So the script here that proved the point was simply to create a new child process. And within that, just use a netcat, and you could get anything from the machine. You could do anything with the machine, but within the rights on which the application is running there. So when I tried to prove the point, I actually showed them that, it's really running there. You get the alert one just like in a web application. And on the background, I had already stolen whatever I wanted to steal. So when it came about to taste the fruits of my labor, I actually found out a really useful truth here. So the framework was rather new. A lot of people were experimenting with it. And when I reported that, guys, you have this code execution vulnerability there, that maybe you want to fix it, then, I got no response back. And, well, that wasn't my first time to get no response back, but I mean, I didn't get to send them even the report what was happening. They were simply not interested, or they think that maybe I'm talking rubbish. But when it came about this second application, this was a Markdown application, and this didn't have a web application version of it. I mean, you could still share your notes, but you would also need to share the Markdown files, which you will then load in the application. But the funny thing here is that there's so many of these kind of applications when it comes to Electron. And often when you launch these applications, they have this really nice welcome page. They're going to welcome you. They're going to tell you, okay, this is the Markdown syntax that you're supposed to be using. But if you go ahead and download one of these applications, and maybe it happens one day you stumble up on one that also welcomes you really nicely, but because the framework allows you this operating system access so easily, then on the background, the author is actually stealing everything from your machine and you have no idea. So, that was what the video was for. Is it playing? I can't see. Okay, so on the right side here, you can see the attacker's machine. On the left side, you can see the victim's machine. The victim is running the vulnerable Shiba Markdown editor. And the attacker will simply listen on a port. And all it takes is a simple birthday greeting. And I've stolen everything I wanted to steal from your machine. So if this is literally not the easiest code execution that you've ever seen on a desktop, but then I really don't know what it is, because the whole script that was used there was literally like one-liner, basically. So, going back to the slides. Okay, so this was another interesting case. As I was moving on with my project a little bit, and I produced some material already. Okay, this is how these vulnerabilities look like. This is how you fix them. And Mo editor was, well, the same as the previous ones. People are really eager to keep their notes. And the vulnerable field here was the application's content field. So anything you paste in there, you're done. And why I bring this example here was a really funny case. So when you think about desktop applications, when you enable people to download and install these applications, they're exposed to everybody out there, right? And if you have a vulnerable version of the desktop application available, okay, maybe you're going to give it a fix. You're going to put it out there again, but then the vulnerable versions are still out there, and it's really hard to update, right? And in this case, I happened to stumble upon a project where I encountered a funny case like this. So I reported it to the original owner that, hey, you have a code execution vulnerability here. And I get no response back. Then months later, I'm gonna write to him again. You know, like maybe you still want to consider it, maybe you want to fix it. And the only response I get back is that he has given the project to somebody else. So I went ahead, found out who that somebody else was, and he was really surprised to find out that he had just inherited an application with a code execution vulnerability in there. Nobody had told him that. And a day later, there came this flag in GitHub that he's looking for help because he did not know how to fix it. So because we're dealing with a desktop application, the application was literally duplicated. So now there was 2 vulnerable versions of the same application out there with 2 separate owners. The first owner did not want to fix it, and the second one simply did not know how to. So if that's not funny, then yeah. But then, in turn, I'm going to talk to you about a Joplin application. Joplin was a really, really good advertised application. It also allowed you to synchronize your data from multiple places like Dropbox or OneDrive, so they were really putting effort to it so people would use it. And here, the vulnerable field was also the very content field where you paste every information that you might want to keep. And the good case here was that when I reported this vulnerability, I had managed to create enough content and blog posts to support what I was telling them. So when I'm announcing that you have a code execution vulnerability in your Electron application, that it actually matters that you're going to fix it. Because at first, people simply would not believe that the fix is worth the time. So this was fixed by the next day. And yeah, I think that was my best case scenario here. And all it took was a small surprise. So, and as a quick takeaway here, I think if you would look into Electron applications, it's still super good playing field to find new things because a lot of it has not simply been found yet. Even if you look at the count of CVEs, it's like less than 10. And if you're seeing any of the applications that Electron is advertising on their site, be really cautious about which one you would use. Check it first yourself. And Electron also came out with their version 2.0 now. So when they started to see that all of those articles were emerging, they had this simple security checklist before, but they really never explained what you're dealing with, how to fix it, how to approach something. So now you can actually take a look and see what's going on within your applications, as well as they give you support when you're managing your applications from the console. So that's also a good thing. And some ideas here would also be that, well, fighting against cross-site scripting vulnerability is already a lost cause. So what if we would change the framework, but to do it in a manner where, okay, maybe the application wouldn't work right out of the box because we would tweak some settings, but what if you would go ahead and turn node integration by default false? So that would eliminate all the cases where you wouldn't actually need the Node.js engine because maybe you're dealing with static pages, but since it's already false, then you don't have to really bother. But if you do need it, you see, okay, the application is not really working, then you would go turn it on. And also to limit the attacker's activities, as the framework really allows you to go really far, what if we would have the functionality there to limit which kind of modules can be required? So anything that's already required within the application, fine, use it. But if you want to require anything more, you cannot do that. So it will limit the functionality you can use. And I think that's it. And thank you.
Okay, thank you, Silvia. Any questions here in the room? questions here in the room? You can find Silvia outside and around, I'm sure, this afternoon, if anybody has anything they'd like to go over. And we're making up for time, and we'll move on to the next speaker. Thank you again.
Thank you.